Good morning, I'm Sarvi, and today I will be giving a Pechakucha style presentation on neuroscience and my major, computer engineering. Specifically, I will talk about neural networks, a type of machine learning algorithm. First, let me give you a little background on what machine learning really is. Unlike human beings, machines cannot read a book and learn its contents. They only understand ones and zeros, and don't associate words with meanings. Machine learning is the study involving giving a system the ability to make inferences and conclusions from data. Let's look at an example of what machine learning can achieve. Here's a picture of the Georgia Tech post office. Machine learning can be used to recognize handwritten characters on letters and packages. Postal services around the world use this algorithm to recognize and categorize packages by zip code. For computer software to be able to recognize characters, it is first given a very large set of images, such as the one shown on the left. The image set includes all different ways of writing each character. It uses a model to translate images into characters. There are many ways to construct a model which will help recognize handwritten characters. Neural networks is one of them. The different algorithms differ in their complexity and computational requirements. Neural networks, although computationally intensive, are preferred for their ease of implementation. Artificial neural networks is an algorithm inspired by the structure of the human brain. Just like neurons in the brain, neural networks form an interconnected pattern. It uses a simplified model to represent the interconnectivity of neurons and transfer of information from one neuron to another. For the purpose of this presentation, I will use the example of character recognition to explain neural networks. This means that the example system will take in handwritten characters, attempt to recognize them, and finally spit out a character that it thinks is the closest to the input character. In other words, this picture shows a single artificial neuron, the bottle cap, which in the neural networks lingo is referred to as a node. This is the smallest building block of the artificial brain. Each of the lines coming in from the left is an attribute of the input, and the lines on the right are the outputs. Using the basic model of a neuron, we can construct highly interconnected graphs that represent a model of the brain. The most common configuration of these nodes is the feed-forward network, with data traveling from left to right, meaning the inputs are fed in to the left of the node and the result is obtained on the right. Let's go into the process of how data travels on the lines in the previous picture. Each line keeps track of an internal number called its weight. The input coming in gets multiplied by its weight on its way to the node's core. As more data travels through the nodes, the weights on each of the input lines gets adjusted. By the word data, I'm referring to the images with all the different ways of writing the character A. In this picture, the weights are represented by the number of coffee beans. It is using these weights that the system is able to store useful information. This is a picture showing the classification of letters based on destination, after a computer running the neural network's algorithm identified the destination using the zip code. The accuracy of using neural networks for classification in post offices is an astonishing 97.5%. Now I'm going to discuss some of the other applications of neural networks. Targeted marketing is one of them. In this case, neural networks help businesses better spend their advertising budgets by telling them which advertisements to send to which customers. Using a patient's list of symptoms, heart rate, blood pressure, and other information, neural networks can be used to confirm and assist doctors with diagnosis. There have been cases where a patient data analyzed using a neural network uncovered patterns that the doctors had missed. Use of neural networks in spam detection is very common. Trained on the user's preference of when they will mark an email as spam, and using email characteristics such as subject line, time of email, sender's email, etc., neural networks are almost perfect at predicting spam emails. Unfortunately, there is no free lunch. Neural networks, although can be trained to have very high accuracy and are computationally intensive and spatially expensive. Also, they cannot handle data that has a time series attribute. To deal with these limitations, researchers have come up with some creative solutions. In order to improve performance of neural networks in terms of speed, specialized hardware is being created, keeping the neural network computation requirement in mind. Think of this as a dedicated graphics card for neural networks processing in research computers. Another area of current research involves combining other machine learning algorithms with neural networks. In this way, researchers are hoping to be able to account for some of the limitations of neural networks while making sure accuracy of the system is not compromised. As has been shown in this presentation, neural networks have a wide array of applications and have shown promising results. This relatively new discipline of neurocomputing that emerged from the intersection of neuroscience and computer engineering still has a long way to go. In conclusion, neural networks are biologically inspired machine learning algorithms modeling the learning capabilities of a human brain. Maybe someday we'll be able to create a model big and general enough to simulate human brain. Thank you.